Okay, good evening. This is Professor David J. De Los Reyes. Okay, my topic for this morning again will be a topic on alternating current circuit, and the topic is actually very important to any household here in the USA or in the entire world because it affects our life because if the power factor of our house is a lagging power factor, okay, actually we are not saving energy and we are actually paying so much money to the utility line. So if we could improve the power factor of our houses or businesses, okay, we got five benefits. The five benefits are actually, before I will discuss this one. The five benefits of using or improving the power factor is actually number one, S will decrease. S is the total apparent power drawn by your household or business enterprise. Number two, the current consumption will also decrease. Of course, if the total apparent power will decrease, the total current consumption will also decrease. Okay? Number three, reduce size of the lines, meaning the transmission lines or the feeder lines used to serve us. The size of the wires will be less, and if the size of the wires will be less, of course the money in what you call this buying that line will be less, so you save money. Number four, power loss on the line will be less also. Okay, and number five, this is the most important thing. It is the so-called reduction in monthly bill. So actually, power factor is very important to us. Okay, let's try to discuss first. Okay, what's the concept of the so-called power factor correction? This is the concept. To raise the power factor, okay, before I will proceed further. This is now alternating current circuit lesson number 11, and the title of our topic is power factor correction. We will try to improve the power factor of our houses or business enterprise. Okay, this is the concept. To raise the power factor of the system, connect in parallel to the system a condenser. We will connect to the system a condenser. System meaning the lines coming from the utility lines, it should be line number 1 and number 2. To improve our power factor, we connect a condenser in parallel with the utility line. Meaning in parallel, it should be in parallel with the total load of the house or business enterprise. So there are actually, it seems there are only two loads. It's the condenser plus the single equivalent of our houses or business enterprise. So their currents will try to interact to improve the power factor. Okay, the figure will be something like this. This is the utility line. This is the feeder lines going to our houses. And what it says on the concept is that we will connect a condenser in parallel with the utility line and also in parallel with the single equivalent load of our houses. So it seems we are only given two loads, is the condenser plus the single equivalent load of our house or business enterprise. They are in parallel with each other. So this condenser here produces a current which is different from the current drawn by the single equivalent load of our house or business enterprise. They act differently. They will try to fight out each other, then try to eliminate this uh, this bad current, because sorry for that. The current being consumed by the single equivalent load is actually, it seems, it's a bad current because it comprises of motor load currents. Okay, it's not so effective in the so-called, what do you call this, apparent power consumption or some other things. So this is actually a bad current. Right? So this bad current will be contradicted by the good current of the synchronous condenser. So a bad current and a good current, it seems it's just like on the cholesterol thing. There is the so-called bad cholesterol and good cholesterol. So for you to be healthy, okay, that bad cholesterol and good cholesterol will try to fight it out each other, and only a minimal thing of the bad cholesterol should, what you call this, should be retained for us to be healthy. And in the circuitry also, it is something like that. The bad current drawn by the motor loads, okay, will be contradicted by the good current produced by the synchronous motor, which acts like a condenser. Because the current produced by this will be different from this. They try to interact, so the bad effect of the bad current will be less. Okay? Okay, let's try to bring out the concept of synchronous motor. Synchronous motor. An overexcited synchronous motor running with no load, when connected in parallel with the supply, it takes a leading current which partly neutralizes the lagging reactive component of the load, thus improving power factor. Meaning to say, a synchronous motor is actually an overexcited synchronous motor which runs with no load, okay, and produces a leading current. Okay, so actually, this synchronous motor here will produce a leading current. Right? A leading current is a good current, and a lagging current is a bad current. Okay? So this leading current fights with this bad current, which is termed to as lagging current, okay, such that we only retain a small part of the lagging current. Okay? We will just retain. So you're meaning to say, just produce an exactly not so much leading current, so this lagging current will be minimized. Okay, so it seems it is like this. If this is the reactive power of the load total motors, if we try to introduce that condenser, this reactive power of the motors will not be something like this, because the QC of the condenser will fight out this QM. So actually the resulting power triangle is actually, it's smaller. Power triangle with condenser, the resulting triangle is actually small. So meaning to say, S is decreased, has decreased. Of course, current will decrease. If the total apparent power is decreased, the total current also will decrease. Okay? For this wire size, it will be less. Okay? So if it will be less, because the current is less, right? So you need a smaller wire, right? Not a bigger wire. So actually you save money. And number 4, power loss is less. Power loss is actually the square of the current times the resistance of the line. Okay? If this current has decreased, even though you square it, okay, this will still be less, right? So if you decrease the current, the power loss of the line will also decrease. And for these 4 conditions to come out, there will be a reduction in the monthly bill. And that is actually very important to every household here in the USA or in the entire world. That's why Mr. Elon Musk is introducing a gadget such that I know that the one inside of the gadget of Mr. Elon Musk is actually a power factor corrector. Because this is the original triangle, power triangle, without that gadget. If the introduction of that gadget, the resulting power triangle will be less. So the total apparent power, the total power drawn by the system will be less, the current will be less, the wire size will be less, the power loss will be less, so there will be a reduction in the monthly bill. And this helps our ordinary household like us. Okay? Okay, that's the importance of the so-called power factor correction using a synchronous motor. And the formula on how to take the reactive power of that condenser, it's an easy thing to do. Just consider the power triangle with the condenser. It is now a smaller right triangle. Theta 2 will be the desired power factor angle. If you want your power factor to be 90%, just place this angle theta here to be 0.9, something like that. Okay? Because if it's 0.5, that's bad. If it's 0.6, that's bad. It's 0.7, it's bad. But if you try to design it such that the value of theta 2 is 90%, meaning it is 90% effective, that's very good. So from this smaller right triangle, tangent of theta 2 will be this side here, opposite over adjacent. Tangent of theta 2 will be QL minus QC all over P. QL minus QC. Okay? This is now the reduced reactive power of the power triangle after the introduction of the condenser. It's very small already, right? Unlike on the first one, it is still very big. That's why we must have to subtract something from here for it to become lesser. So tangent of theta 2 will be QL minus QC over P. Solving for QC, right? QC will be equal to P tangent of theta 2. But I expedited this one. P tangent of theta 2. Okay, we cross multiply theta 2 equal to QL minus QC. So solving for QC, we put QC on the left, it will now be plus, so it will be QL, and this one we will pull it on the right, minus P tangent of theta 2. It is this, right? And the unit of this is actually bars. Okay, reactive volt ampere. If it's a very big condenser, this should be kilobars. And if it's a bigger one, it should be megabars. Meaning million reactive volt ampere. Okay? So actually, you could design, you could compute for the value of Q sub C, which will give this one. If you want this to be 90%, just place 90%. And you can compute for QC, which will make the power factor 90%. Okay? So this is just a formula. Okay? This Q sub L was the total reactive power of all the motor loads, which gives a bad current. That's why we must have to contradict some of those for the power factor to rise to 90%. And actually, if you put this to be 90%, you could compute for the value of the reactive power of the required synchronous motor in terms of kilobars or megabars. As easy as that one. Okay? Okay, that's it, guys. This is just a lecture on all of us, including my co-creators, which are not electrical engineers. But for those who are electrical engineers, you know this one, guys. Okay. So for those of you who are taking up electrical engineering, this is for you guys. power factor correction is actually very important in our everyday life because it gives us 5 benefits. The total apparent power drawn by our system will be less, current consumption will be less, the wire size of our power lines will be less. If the power lines has a reduced size, okay, we save money if we buy it, right? The power loss will be less. Because if the current is less, even though you square it, okay, it will still be less. And the last thing that will benefit us is actually the reduction in the monthly bill. And this is good for all of us. Okay, this is Professor David J. Reyes. Good morning from Los Angeles.